Welcome to Cint International Tutors. We are committed to bringing knowledge and skill to your doorstep. This video is on how to do test of normality in SPSS. After watching this video, you will know how to do test of normality in SPSS. However, before watching this video, please go to the presentation titled Module 1, Introduction to Non-Parametric Test and Test of Normality, for the basic concepts of test of normality and the databases for the analysis to be covered in this module. What is the basis for doing test of normality? Test of normality is performed to determine if a data set is normally distributed or not, in order to know the appropriate statistical test to be used in analyzing it. That is, whether parametric or non-parametric. This is because one of the assumptions for most parametric tests to be reliable is that the data set is approximately normally distributed. However, data does not need to be perfectly normally distributed for the test to be reliable. Let us start with test of normality 1. For this analysis, please open the presentation titled Module 1, Introduction to Non-Parametric Tests and Test of Normality, to access the data set indicated below by clicking on the link to it. The data set for test of normality 1 has been opened. It contains two variables named as weight underscore male and weight underscore female. To do test of normality, click on the Analyze tab. Click on Descriptive Statistics and click on Explore. In the Explore window that opens, click on each of the variables and click on the arrow next to them to move them to the dependent list box. Click on the Statistics button. In the Explore Statistics window that opens, descriptive is already checked by default. Click on Continue. Click on the plus button. Go to the descriptive section. Stem and leaf is selected by default. Deselect it. Select histogram. And select normality plus with test. Click on Continue. Click on OK. The results are displayed in the output viewer window. For the variable weight underscore male, the mean equals to 45.5, the median equals to 45.5, the skewness equals to 0, which shows that the variable is normally distributed. For the variable weight underscore female, the mean equals to 47.48, the median equals to 7.5, and the skewness equals to 0.013, which means that the variable is approximately normally distributed. Similarly, both the common gauge per alpha and Shapiro-Wilk test gave p-values greater than 0.05. Since the null hypothesis for this analysis is that the data sets are normally distributed and the null hypothesis is not rejected, it therefore shows that the data set is normally distributed. Similarly, the histogram for the variable weight underscore male is bell-shaped, which suggests that the variable is normally distributed. The QQ plus also shows that the data points are along the diagonal line, which suggests a normal distribution. The box and whisker plot also shows that the middle line is at the center of the box, that is the median, and the whiskers on both ends are of equal length, and there are no outliers, which also suggests a normal distribution. For the variable weight underscore female, the histogram also appears to be bell-shaped, which suggests a normal distribution. The QQ plus also shows that the data points lie along the diagonal line, which suggests a normal distribution. The box and whisker plots also show that the middle line is at the center of the box, and the whiskers on both ends are of equal length, and there are no outliers, which also suggests a normal distribution. Let us now proceed to test on normality 2. For this analysis, please open the presentation titled Module 1, Introduction to Non-Parametric Tests and Tests on Normality. To access the data set indicated below by clicking on the link to it. The data set for test on normality 2 has been opened. It contains a variable named as A. To do test of normality, click on the Analyze tab. Go to Descriptive Statistics and go to Explore. In the Explore window that opens, click on the variable age and click on the arrow next to it to move it to the dependent list box. Click on the Statistics button. In the Explore Statistics window that opens, Descriptives is shared by default. Click on Continue. Click on the plus button. In the Explore Plus window that opens, stem and leaf will be selected by default. Deselect it. Select histogram and select normality plot with text. Click on Continue. Click on OK. The results are shown on the viewer window. The mean age equals to 7.5 years. The median equals to 6 years. And the skewness equals to plus 1.043. We suggest that the data set is extremely positively skewed. Also, both the Comogos runoff and the Shapiro-Wilk test gave p-values less than 0.05. And this means that the null hypothesis is rejected. And since the null hypothesis for this analysis is that the data set is normally distributed, we therefore concluded that the data set is not normally distributed, and in actual fact, is extremely positively skewed. Similarly, the histogram shows a long tail on the positive side, which shows that the data set is positively skewed. Also, the QQ plots show that most of the data points deviate from the diagonal line, with most of them lying below the diagonal line, which suggests that the data set is positively skewed. Likewise, the box and whisker plot shows that the middle line lies very close to the lower border, with a short tail on the lower side, while the upper side has a long tail with outliers, which suggests that the data set is positively skewed. We are now going to do test of normality 3. For this analysis, please open the presentation titled Module 1, Introduction to Non-Parametric Tests and Tests of Normality. To access the data set indicated below by clicking on the link to it. The data set for test of normality 3 is open. It contains a variable named as age. To do test of normality, click on the Analyze tab. Go to Descriptive Statistics and go to Explore. In the Explore window that opens, click on the variable age and click on the arrow next to it to move it to the dependent list box. Next, click on the Statistics button. In the Explore Statistics window that opens, descriptives will be selected by default. Click on Continue. Next, click on the plus button. In the Explore Plus window that opens, stem and leaf will be selected by default. Deselect it. Select histogram and select normality plot with text. Click on Continue and click on OK. The results are shown on the viewer window. Under the descriptive table, it shows that the mean age equals to 14.48, the median age equals to 16. and the skewness equals to minus 1.079 with a standard error of 0.223. Since the value of the skewness is less than minus 1, it shows that the data set is negatively skewed. Similarly, both the Kolmogorov-Smirnov and the Shapiro-Wilk test gave p-values less than 0.05. The null hypothesis for this analysis is that the data set is normally distributed. And since the p-value is less than 0.05, null hypothesis is rejected. It is therefore concluded that the data set is not normally distributed, and in actual fact, it is negatively skewed. Also, the histogram shows a long tail on the negative side, which implies that the data set is negatively skewed. Also, the QQ plots show that the majority of the data points deviate from the diagonal line, with majority of them lying above the diagonal line, which implies that the data set is negatively skewed. Similarly, the box and whisker plot shows a long whisker on the lower side with outliers, which implies that the data set is negatively skewed. Thank you for watching this video. I hope you found it helpful. Would like to inform you that the student-friendly statistics for health, life, and social sciences book is now on sale. To buy a copy or copies of the book online, please click on the link shown to access the order form. You can also access the Cint International Archive journals by clicking on the link shown. You want to publish with us? Please submit your manuscript at the address shown. Finally, if you want to receive notifications on our subsequent videos, please subscribe to this channel by clicking on the subscribe button.